Hey there, welcome to another episode of ecoLEAD. I'm your host, Onoja Simeon, and I'm excited to be joined today by a very, very special guest. Someone whose work I find particularly interesting. And today, we're discussing his research on how chemicals added to different types of microplastics during manufacture can interact with the skin due to our inevitable exposure to microplastics. Dr. Abafe specializes in using advanced chromatographic and mass spectrometric techniques to analyze trace levels of chemical contaminants in various environments, including human tissue. He focuses on linking environmental pollutant exposure to their impact on the human body using next generation tools like 3D models and human biomonitoring. Before joining Brunel University, where he currently works as a lecturer in environmental sciences, Dr. Abafe was a Marie Curie Individual Fellow at the University of Birmingham. He also served as a senior research scientist and laboratory manager at the Agricultural Research Council under Stepot Veterinary Institute. Dr. Abafe has led numerous projects and training programs for the United Nations Food and Agricultural Organization and the International Atomic Energy Agency. In 2021, he received a Y1 rating from the National Research Foundation of South Africa, recognizing his potential as a researcher of significant international standing. So, seeing that you are already familiar with my voice, I'm sure you are excited for me to be turning over to our guest and meet our guest. You shall. All right. Thank you for agreeing to come on the show.
Thank you.
Greatly appreciated.
Good.
So today, we are going to be talking about your very interesting paper. I found it very interesting, and it's novel insights into the dermal bioaccessibility and human exposure to the brominated flame retardant additives in microplastics. And as I'm sure you know, I did some work on microplastics.
I remember.
I didn't quite get it to that point where, every time we do these microplastics conversations, people always take it to that place where they ask, okay, we found microplastics everywhere, but so what,
Yeah.
And so when I found your paper, I found it really interesting, and I said, anything it takes, I'll find you.
Okay, yeah. It's good to hear that you find the paper very interesting.
Yeah.
So that's good.
Yeah, so just to have a bit of background, how did you find this field, and how is the field treating you so far?
I would say it's been quite an interesting journey for me. I'm a chemist, BSc chemistry up to PhD level, and my research has basically centered around the environment and human health. So my interest in the field really stemmed from my growth. from the area where I grew up. I was born and raised in Nigeria, as you may know.
Yeah.
And basically from the Niger Delta region of Nigeria, where we have a lot of pollution-related issues.
Yeah.
So that's basically what sparked my interest in environmental chemistry, human health, and public health.
Interesting. It's a bit similar to my experience too. I remember growing up. So where we lived a bit close to where the Kaduna refinery used to discharge their waste, and frequently would see dead fishes on water. And to us then it was like blessings from God.
Blessings in disguise.
So it was later when I go into the field I started understanding and I realized that no, that's not blessing, that's actually death in disguise.
It's usually the case. Although for some of us we knew from the onset that dead fishes in the river could mean something else, because we know we do have a lot of fishermen around, and sometimes they use carbide for fishing, and we know that the fishes that come from the river with carbides are not very good for human consumption. So we know whenever you find a dead fish in the river, there's something associated with it. And unfortunately, we have lots of oil wells around our villages, our towns, and we could see visible pollution, so contamination of some of our rivers, even some of our borehole waters. You could visibly see the oily contamination in the water. So from the very young age of secondary school, I already had an interest in chemistry and wanting to provide solutions to pollution problems.
I see. You were obviously more prepared for the business than I was. Anyways, coming to the research, can you give us a bit of background on this particular study? What was it about and things like that?
Yeah, as the title says, it's about providing novel insights into the conundrums associated with microplastics. Microplastics have been detected on almost every environmental media, even in human body.
Yeah.
People have measured it almost everywhere. But there is this debate around the scientific community and between science and policy, where policy says there is no enough toxicological evidence to support regulations on microplastics.
Sorry. When you say toxicological evidence, can you break down a bit? What exactly do you mean
so
by that?
What in simple term, one would say, we have not, policy says they don't have
enough evidence that it
enough
causes
toxicity to humans.
Yeah.
Hence, it's a bit difficult to regulate, you know. But again, if you look at the basis of science, the absence of evidence does not mean that the toxicity is not there, you know. So, within our own ability at that time, we decided to look at what happens if microplastic come into contact with the human skin, because we've seen that the skin is exposed to almost every contaminant that is there in the environment, and you may know that the skin is the largest body organ that we have as humans, so it's on daily basis exposed to every external contamination that we come into contact, so from air pollution, from atmospheric deposition, to anything that comes into contact with your skin. So it's very important for us to see if microplastic if anything happens with microplastic, when it comes to this, come in contact with the skin. So the study basically was looking at toxic chemicals that are present in microplastic. There has been a few studies showing that when people get exposed to microplastic, it could result to what they call the particle lesion. But other than that, there is really no other much human health related toxicity that have been reported regarding to microplastics. So we thought it wise that let's see, even though there's no much knowledge about microplastic itself, we know that plastics during their formation, they use different kind of chemicals, which we call additive chemicals. Some of these chemicals have been shown to be highly toxic, with a lot of studies out there, a lot of human studies out there that shows that they can be endocrine disrupting. Some can have reproductive effects, some can have a hepatotoxic effect, and different kind of effects on humans. So one of the major culprits in terms of the toxicity of the toxic chemicals that are found in plastics is the brominated flame retardant. So we decided to study brominated flame retardant because there is enough toxicological evidence on the toxicity of brominated flame retardant. But we do not know if, when we get exposed to microplastic, the brominated flame retardants in those plastic would have any effect on us. Because for there to be an effect, the chemical in the plastic must first be released onto the skin or onto the surface that it touches. So the study is just looking at or studying if these chemicals would leave the plastic particles when they get into contact with our skin, and then, which means, would the additive chemicals leave the particle and then sit on our skin or not? So that's basically the first step in toxicological studies, when you want to know if the particles could present issues related to brominated flame retardants. So that's the background to the study.
Yes. So were you looking just at brominated flame retardants, or were you looking at all the broad range of hazardous chemicals that are incorporated in plastics?
There are millions or thousands of chemicals that can be found in plastics, from the ones they call plasticizers to pigments to fillers, then to flame retardants. So it's very difficult for one to look at the broad classes of chemicals that are present in plastics. So basically, for this very study, the one you have referenced, we're looking at brominated flame retardants, which are usually used as flame retardant in plastic, in the production of plastics. Yeah.
Interesting.
Yeah.
All right. That's I find it very interesting because, like I said, I was more or less looking at the initial aspects in my last research. So this is very interesting. So can you explain a bit without going into too much of the science?
Okay.
So because yes, we understand this is what you were trying to do. How did you go about doing it? Like, what was the methodology in summary? But the whole idea of what we're doing is, I don't want my listeners and my audience crashing at this trend and the weight of the science.
No, that's fine. We'll try to make it as simple as possible. We know that the human skin is filled with what we call the surface film liquid, which otherwise we call sweat and sebum. So those are the fluids that we find in our skin. So sometimes when you're jogging, or even when you're sitting in a hot environment, you start what we call sweating. So the sweat itself, is the composition is both sweat and sebum. So sweat is produced from the sweat gland, and then the sebum is produced from the sebaceous gland. So the first thing that we do in this kind of study, where we want to look at the chemicals, if they are released from the microplastic onto the surface of the skin, is to mimic the skin as much as possible and the composition of the skin as much as possible. So in this case,
sorry, just to cut you a bit there. Why can't we just go and get skin from people and use it for the experiment?
Getting skin from people, you won't be able to simulate sweat on the skin itself. So the first step is you want to see if these chemicals are released into the fluid that the skin contains. In this case, is a surface film liquid, right? Which is composed of the sweat and sebum. So our interest is to produce sweat and sebum in the lab, and then study the contact of microplastic with sweat and sebum, and see if the brominated flame retardant will be released from the particles into the surface film liquid. So that's basically what we refer to in this area of research as bioaccessibility. So the amount of the chemical of the flame retardant that leaves the particle and gets into that biological fluid, which is the surface film liquid, is called the bioaccessible fraction. So this is the fraction of the chemical that is available for systemic absorption, which means when you come into contact with microplastic, that amount that is released from the microplastic into this the surface film liquid is the amount that you can be exposed to in such a way that that is the amount that will come into the skin, and then depending on the ability of the skin to protect you, that can penetrate or not. So that is what is available for absorption.
So you were able to, we'll come to the detail of what you found, because that's the next question I'm going to ask, like the major findings. But what you were looking at basically is what quantity or concentration of the pollutants leave the plastic and rest on the skin.
No, that gets into the surface film liquid, which is the sweat sebum.
On the surface of the skin, not inside.
That can be found on the surface of the skin, because that is what you get exposed to. You can get exposed to microplastic, and if the chemical does not leave the microplastic, it doesn't pose any harm. So we needed to study how much of it comes out of the plastic before we can know how much of it that will go through.
So for this particular study, you didn't take it to the next step of trying to see how much of it eventually ends up in the human body.
No, for this study that you have referenced, that is not part of it, but we have done a study that was published early this year on the amount that passes through the skin. So
that means you're definitely coming back.
That's we can talk about that.
I see. Okay, so if we stick to this one then, we know now, I'm sure most of my listeners and audience would agree and would know that there are lots, even in the atmosphere now, we have atmospheric plastics and all of that. So which other routes of exposure would you identify, or would you talk about? We're talking of it on the human skin now. just by walking around, atmospheric is an issue.
Yeah.
What other ways of exposure do we have apart from
to the skin?
Yeah, to the skin.
If you look at dermal exposure, there are quite a number of possibilities with which we get exposed to microplastics. The couch we're sitting on, it's a potential source of microplastic. Some of our non-cotton clothes, some of our jeans, our shirts that we wear, could expose us to microplastic particles. And then lying on the sofa, sometimes the sofa, even your beds, the carpets in the house could potentially be a source of microplastic that you get exposed to, or that the skin gets exposed to on a daily basis.
And then there are some cosmetics.
Depending on the country, in the UK and most part of Europe, or in Europe generally, the use of microbeads in cosmetics has since been banned. But in some other countries, the possibility of the use of microbeads in cosmetics is still possible.
Interesting.
Yeah.
Wow, this is interesting. Thank you. So, what are the striking findings without going into too much science again?
Yeah.
What are the things you found that were like, wow?
Yeah. The study was generally quite surprising. Many of the results I found were quite surprising in that we could see flame retardants, brominated flame retardants, getting out of microplastic to as much as 80%, depending on the kind of polymer that they are contained in. In terms of microplastic, there are different kind of polymers that can be present. So depending on the kind of polymer, brominated flame retardants in microplastic could be released to as much as 80% into the surface film liquids.
Wow.
Yeah, so that was a striking one. And then like I mentioned earlier, the type of the plastic plays a lot of role. And it was quite surprising to us because we were thinking that when you get exposed to plastic, all the plastic should act the same way. They should expose you to as much or to as little as possible kind of contaminant that's in there. But that was not the findings that we got. We really see that depending on the type of plastic, the amount of the chemicals that is released could be significantly different.
And the kind of plastics you were looking at are like everyday plastics.
Everyday plastics,
polypropylene,
very popular plastics, polyethylene, polypropylene, and polystyrene, which are some of the most used kind of plastic polymers.
So this is me being a bit crazy now, but it therefore means that if my skin is exposed to that level of brominated flame retardants, and for some reason my sweat gets into my mouth, that's me drinking 80% concentration of brominated flame retardants, isn't it?
Yeah, it depends. It depends again on how often you'll be drinking your sweat.
My sweat,
and the kind of plastic that you get exposed to, because not every plastic will give you 80% of brominated flame retardant in your skin.
I see.
Yeah.
So, in summary, everyday plastics that we use, most of which are incorporated with things flame retardants, brominated as an example.
Yeah.
Come in contact with our skins and have the capacity or ability to release some of these
toxic chemicals that are in there
on our skin.
Yeah.
That's very interesting. Is there any relationship between the size of the plastic you're exposed to and the amount of the flame retardant that ends up on the skin?
Of course. We did find that the smaller the particle size of the plastic, the more the flame retardants that are released. But this is quite obvious in chemistry because the smaller the particle, the larger the surface area. So there's a possibility of releasing more of the chemical. So we found that the smaller the particle size, the more the brominated flame retardants that are released into the surface film liquid. I'm trying to
I understand.
Skin,
I understand
because it's not the skin, it's the surface film liquid.
I see. And then did you take it as far as looking at the level of exposure as per different? So maybe children have more risk than adults or elderly people. Any such differences?
Yeah, we did quantify human exposure using different kind of characteristics and parameters in exposure assessment. Yeah, we did find significant exposure for some population group, especially for kids. This is basically because of their frequent contact with plastic related articles. The number of time that they spend in the indoor environment as well. So there are different parameters that are counted for that. So, but generally both adults, teenagers and kids are exposed to very large amount of flame retardant. So in generality, we found that microplastic is a significant source of human exposure to brominated flame retardants.
I see. Yeah. By microplastics, you're talking about plastics that are below 5 millimeters?
Yeah, by definition of microplastics.
Okay.
Tiny particles, less than 5 millimeters. Yeah.
I see. And then based on what you've done, maybe not strictly on this research, but generally speaking, are there any precautions that you think individuals can take to minimize exposure, things like that?
Yeah, I think generally there are quite a number of ways with which one can minimize exposure to say microplastics, especially looking at the skin. I mean, the one that will come in contact with the skin. Some of the recommendations that we have is possibility of limiting potential sources. I mean, in the indoor environment, I mean, within your home and your office, there are quite a number of sources of plastic, from your computers to your chairs to your couches to your foam. There are potential sources of microplastic. So the minimum amount of these kind of articles that you have, the less likelihood or the lower the amount of microplastic that you'll be exposed to within that space, you know. So limiting possibilities of contact with plastic within the home, it's the first way of limiting exposure. And then when you get exposed, because at the end of the day we'll be inevitably exposed, I think bathing, especially with the skin, frequent bathing, not bathing more than once or twice in a day, could help minimize the exposure time.
Sorry, did you say bathing more than once or twice a day?
Maybe twice, in the morning before you go out, and in the morning before you go out.
That's going to lead to another fight.
Yeah,
we're trying to cut down on use of water.
So, or you can it all depends again, you know, on the scale of preference and on what is more important, you know. Getting out, because atmospheric deposition, you cannot really control that. So it's very important that when you get home, you can have a shower before going to bed, you know, just to clean your body, reduce the amount of microplastic that you've carried from outside.
Perhaps, I don't know if this was part of your findings, but maybe the longer the plastic stays, the more the pollutants would leach out. Did you notice anything?
Yeah, we didn't study that for too long. The exposure assessment was done for an hour, within an hour period. So we did have the 24-hour studies as well, and it's the more the exposure, you know, it's more like, should I use the word? I don't want to use common sense that the more you get exposed to a thing, then the likelihood, because there's a continuous exposure, you know. But generally, when you minimize exposure by every means possible, you should be able to minimize the incidences of flame retardant within your skin surface film liquids.
I see. Yeah. And when you say microplastics, did you consider things like microfibers, which obviously are the ones we get more exposed to through fabrics and all this other? Did you look at microfibers?
No, for this study, we're just looking at microplastics strictly on polyethylene and polypropylene, as well as polystyrene.
Oh, I see. Yeah. Interesting findings. Yeah. All right, and then I know you said you've done another study now, but I was going to ask what other directions you think this microplastic research would be taken now? Where do you think we'll be going from here, considering how far we have come based on your research with these and the things you've done now? Where do you think we are now as far as understanding of the microplastic situation is?
Yeah, I think there's no gainsaying that the world is not aware that humans are exposed to microplastic on a daily basis via different routes of exposure. So we know we are fully exposed to it, and everyone has acknowledged that. The direction is providing more toxicological evidence to support regulation, and then for policymakers to act on the results that have been presented. And even before results, there should be some strict regulations in place to minimize human exposure to microplastic. Like you mentioned, we've already done exposure to the skin to see if microplastic crosses the skin barrier to get into, the toxic chemicals crosses the skin barrier.
Do you want to give us like a taster? Just give us an idea. Before we jump into that next time.
That's what I'm trying to say. Looking at the if those chemicals that are released into the surface film liquid penetrate the skin and get into the human blood. So we have studied that, and we have the result for that. You can have a look at that study as well. Okay. But there are other aspects of exposure. Ingestion is known to be one of the main routes of human exposure to microplastic. Toxicological studies relating to ingestion of microplastic is also still at the infantry. So we need more.
Sorry, I'm cutting you, but okay. I don't want to lose my chain of thought and the question I'm trying to ask.
That's fine.
What do you think are the barriers to us taking that particular quest? Because it's one that has been lingering for a while. Mm-hmm. If we're able to get a break now, we say definitely once plastic gets here, it causes this. Then we'll be able to get more legislation in place and stuff. So what do you think is the barrier?
I think the barrier could be first ethical constraints with the handling of biological samples, strict biosecurity measures, and then limited techniques to study, to do such kind of study. Currently there's really no uniform ways of measuring microplastic across the world. And then when you want to look at biological organs, there are a lot of regulations that are in there, and then you need to devise means to be able to overcome such challenges. And that's where it's very important you look at the other study where we use the 3D human skin equivalent model, because it's very difficult for you to get human in vivo skin.
So that means you kind of more or less like simulated skin. Used it for
not simulated. Maybe at that time we can discuss more about that. It's more of 3D human skin, which is cultured from normal human cells.
I see. So. Yeah, there's this research I saw recently where they say they found I don't know if you saw it, microplastics in human testicles. And dog testicles. And then not quite 3 weeks after that particular study, another one came out in China where they actually found microplastics in human semen.
That was actually the second study, I think, human semen. There's been microplastic have been reported in many human internal organs, even lungs, human lungs, even human blood. So we are exposed to it. There's no doubt about the exposure because it's been detected in our internal organs, which is enough evidence to show that we are exposed to it. But then we need to support regulation with the toxicological evidence, which regulatory bodies are saying that they don't have, so that there are no data in terms of that. So ethical challenges in handling human samples is one of the reasons why I think studies in this area are quite limited, so
I see. And while you were talking there, I actually thought of something. So brominated flame retardants, yes. Are there alternative things? So is there a way of us saying, okay, I'll go for this kind of plastic because hopefully it's not going to contain these toxic materials that could affect me? Is there any such advice that we can offer?
It's a bit difficult at this point to say this is a non-toxic kind of plastic or this is a toxic kind of plastic. I know other than issues of brominated flame retardants, there's been issues surrounding sustainability where plastic usage, because of the pollution problem we have had with plastic even in the ocean, is driving the change in our consumption attitude, so there's a move to bioplastics, so we haven't really studied the content of flame retardant, if there is any in bioplastics, but there is the shift towards bioplastics, which are supposed to be more sustainable compared to conventional kind of plastics, But in terms of conventional plastics, there's really no one I can say this one is safe and this is unsafe.
The recycling code gives you an idea of the kind of so like PVCs, most plastics that are made from PVC, people always say those ones can be a bit more, the risk from those might be higher than other ones, but now you're talking about PE and polyethylene being this. So I mean, like you said, I think you're right. It's just us waiting for when, hopefully, there will be an alternative to many of these problems.
We're hoping that we could get alternatives.
And then there's this risk of trying to solve one problem and creating a bigger problem, because you and I were talking about this study where is it paper straws having more PFAS than it's such a crazy thing, isn't it?
Studied by some of our colleagues in Belgium.
Okay, you are familiar with the research group? I see. All right, to round up, what key message would you want an ordinary person? Because the essence of what we're doing here is we're looking at this hard work that you all do in the labs, and not just in the lab, you go out to very dangerous fields to work to. And we're looking at how individuals, everyday people like myself, can take the key findings and see how we can apply these things to our lives. So what key message would you say an ordinary person can take from that hard work that you've taken your time to break down for us in the last couple of minutes?
The key message is that we are all exposed to flame retardants, brominated flame retardants arising from exposure to microplastics. So, and we all have a collective responsibility to minimize our usage of plastic. Let's make greater choices and sustainable choices by first avoiding potential sources with which we can be exposed to plastics or these kind of chemicals.
I'm going to finish with something. Just last week, I don't know if you heard, but in this country now, doctors have been advised. Have you heard of eco anxiety or eco? Is it eco anxiety?
Yeah.
What's that? Yeah. Where people are becoming very scared. I don't know if I should say people should not be scared, but again, I think there's a need for some positivity. So I like ending my conversations on a positive note. And mostly I think it will center around where we started from, how far we have come, and that at least there's hope if we do certain things.
Of course.
So would you have any such message in that line?
For us, science shouldn't be about scaring people. It's about letting people be aware of what it is,
the evidence.
And the responsibility of healthier choices or of sustainable choices lies within us. We can make the little changes that we can, but just making some changes in habits in terms of our consumption. So,
all right, thank you very much. We appreciate this. I'm sure my listeners would take a lot of things from what you've said, and hopefully we'll get you back soon.
Anytime.
A lot of things you've been working on. I see your work. You've done some things on PFAS. You've done a lot of things, and if some of you have questions, specific questions that you like me to send or to communicate to him, feel free to leave them.
So that's it for today's episode of ecoLEAD, brought to you by Onoja Simeon. Music is by bensound.com. And please don't forget to check us out on our social media platforms, Instagram, Facebook, and also on YouTube at ecoDR1. That's eco, capital D, small letter R, 1. Stay curious, stay informed, and keep making those greener choices.